Yo guys, it's that time again. Now, if you remember, not too long ago, IBM sent me a drone and challenged me to put AI into it with a deadline. And I was unable to complete it. Now, we may have lost the battle, but we didn't lose the war, cadets. Parade bite! So, I promised you guys a part 2, so this week, I'm gonna deliver that to you. And get hyper, because I've been thinking of an exciting new approach to try that I think is going to be miles better than the last implementation. So with the last implementation, we trained an image classifier to detect when I'm too far away, too close, too far left or right, top or bottom, etc, etc. Which admittedly was a foolish way to try and train an AI on how to move. Well, at least with the uniform data that I was feeding it for training. I honestly believe that this approach could be a good practice for a production-ready solution, but it would have to be a lot more involved. Maybe using machine learning libraries like PoseNet or YOLO and the like for human and object detection, an embedded recurrent neural network to be able to predict motion behaviors, facial detection for framing, and the whole works. An all-around more involved algorithm. But unfortunately, I didn't have much time on the last go-around to think about, let alone involve all of this. And unfortunately, I'm just not interested in spending the next few months building such a solution, especially at the fact that how many guys said that this already exists. So we're going to implement something a whole lot simpler, but should be enough to get the job done. What is this mysterious technique, you're curious? Well, instead of training an image classifier to just hope that it makes sense of the pixels on what to do, we're going to use a facial recognition algorithm that gives us a bounding box where the face is. Then program our drone to keep this box as center as possible, while at a certain distance. And I'm feeling pretty good about this solution. All throughout Christmas break, I couldn't get my mind off of it. So without delaying any longer, let us begin. Thanks to part 1, we already got the tello to output the video stream. So, next step is to, well, when trying to complete any project, I think it's very important to keep your goal in mind so you don't get lost or confused along the way, especially when it comes to machine learning projects. So, let's make what I like to call a ladder, which we will start with our destination and work backwards. And here is what I came up with. Now ultimately what we want to do is be able to launch the tello and have it track any face. But in order to do that, we have to hook up some functionality to the tello output controls. But before that, we need to create a function that maps bounding boxes to the center of the screen. But before that, we need to simply just get a facial bounding box to return from the camera feed. And that's all that's to this ladder. A pretty short and hopefully easy to climb ladder. But now that we have it, let's start climbing. First things first, we need to implement the facial recognition algorithm that will return to us a bounding box of the faces that it detects, which we'll be using OpenCV for that, because this is a library that has facial recognition built in. And I mean, you can't beat a sample platter, am I right? So I plugged in OpenCV's facial recognition algorithm with only a few lines, and got it returning a bounding box of my face. Perfect. I mean, well, it's not perfect. Sometimes it marks random objects as faces when they clearly aren't. It pretty much doesn't even work with profile shots. And sometimes it can't even detect mug shots. But I don't know if it's because the tech just isn't up to snuff yet, or if the algorithm has a bias for lighter skinned folks or not. Listen, either way, it works good enough for me to not want to search for an alternative. So we're gonna roll with it. And just in case you're wondering how this stuff works on a lower level, with OpenCV, you can use what's called a cascade classifier, in which you can train using a few hundred samples of a particular object. So like say a face or a car, what have you. Then once it's trained, you can apply it to images to identify what it was trained on, which opens up a new option for us. We could train our own cascade to get more control over algorithm, but ain't nobody got time for that. Now that we're getting our bounding box returning from the camera feed, next we need to create our function that will map to our tello output, which is gonna be a pretty hands-on process. But first things first, we need to get the center of the screen and the center of the bounding box so we can use that for the tello output. Now, getting the center of the screen is really simple algebra. We just need to take the dimensions of the video resolution and divide the height and width in half. And Boom, center of attention. Now, in order to get the center of the bounding box, it's also a relatively simple equation. Say we have this simple 10 by 10 image, and this is vertex 1, 2, 3, and 4. Well, in order to get the horizontal center, we simply just need to get either the average of vertex 1 plus 2 or 3 plus 4, because they are both connected vertices along the x or horizontal axis, meaning they share the same x values. And vertex 1 plus 3 or 2 plus 4 for the center of vertical, because they are both connected vertices along the y or vertical axis, meaning they share the same y values, which would give us the x and y coordinates of the center of the bounding box. And for an even quicker shortcut, you can just take the average of one diagonal corner with the other, and that'll quickly get you the midpoint between them. Bada bing. Now that we have the center of screen vector, which is a constant, meaning it will always be the same no matter what, and we have our centered bounding box vector, we can now use all of this data to calculate a new vector, our distance vector. But, okay, wait, before we do this, I should probably explain the vectors a bit, otherwise it might get a bit confusing from here. Though I promise it's a really simple concept. So let's go through this thoroughly. A vector is just a container of data. At the fact you're watching my video, you probably interact with vectors every single day. For example, this video's resolution is a vector of 1920 pixels by 1080 pixels. So in today's case, it's just a container of a couple of numbers. A vector by itself has no real value. It is up to us as developers to give it its value. And what we want to do is turn these seemingly valueless vectors into spatial coordinates to use in our actual real-world space. So we have our center of screen constant vector, which is 480 by 360, half of the telo's resolution, and our bounding box vector, which is variable. So we'll just say it's tx by ty. Now, let's make our lives a lot easier and rename these vectors to reflect their purpose. We will now call the center of screen vector true vector, because it's the center of the screen and that is the true location of the drone as far as we know. And the bounding box vector will be called target vector, because the bounding box is the target vector that we want the true vector to meet. Okay, all pretty simple, right? Next, we need to calculate a new vector that we'll call distance vector, which will simply be the distance from target to true, which simply we just subtract target vector from our true vector, and that gives us, well, the distance between the two. Yo guys, I made a little oopsie daisy on this part, and I just want to clarify for all you guys interested in the maths. So this equation will still work the exact same so long as we understand what it's outputting, and you'll see that a bit later. But I meant to design the equation to be target vector minus true vector, because that will return a vector with the actual distance and direction. But this currently, it only just returns the accurate distance and inverse direction. Not the biggest deal, but let's get on with the video. And in order to center the face on screen, the distance vector has to be as close as possible to a 0, 0 vector. Give that a test and... ah yeah. Okay, now we have a slight problem. You see, our drone isn't locked in 2D space. It's not stuck in one spot like this webcam we've been testing on. This thing can fly in 3D space, baby! And so, we have to figure out some way to give it a z-axis. I think I got it. So lucky for us, this default mugshot face cascade that we are using does detect faces of different sizes. So we simply just need to get a better understanding on how that works, then use it to our advantage. After a little experimenting, it appears that it returns bounding boxes with a few different fixed sizes. And so, we just have to pick which bounding box size is the distance that we want to target, which turned out to be 304. I don't know, it just looked like the right framing. But now that we have that, we can now add that as the z value to our target vector. Then to get the z value for the true vector, we just need to take the area of the bounding box, which is just the length of any side times itself or squared, and that will give us the z value for the true vector. So now, if we test it again telling our distance vector to try to be at a 0, 0, 0 vector, boom goes the dynamite. Okay, sweet. So far so good. But before we turn over controls to the AI, we have to do something a bit more tedious. You see, I originally downloaded this Tello script from the developer Daimia Fuentes' GitHub, and the library that he used to display the Tello video feed was Pygame, but I don't really know how to use Pygame yet, and by looking at it, it looks a lot more complicated than it needs to be right now. So we need to convert this entire script to use OpenCV instead. Which means first, getting the teledrone to display the camera feed using OpenCV. Check. Ignore the blue coloration though. Then we need to add just a simple face detection algorithm, make sure everything still works and is good and all that stuff. Check. Now, we can add the full algorithm that we wrote using the webcam. Check. And we're done. Okay, I know it didn't seem tedious, but that's only because with editing I can skip to it. You get it. And now, ladies and gents, boys and girls, bags and baguettes, it is time. It is time to hook up the controls. So, let's slow down. Right off the bat, what do we know? Well, we designed it so that vdistance.x, that's distance vector's x value, got it? Got it? Okay, good, all right. Will return a positive number if vtarget.x is left of vtrue.x, and negative if right of vtrue.x. Now, again, remember, we're trying to get our v-distance to a vector of 0, 0, 0. So hooking up these controls to turn right if v-distance.x is negative and turning left if positive will allow the telo to try and center the face on the x-axis. And the other two axes are pretty much the same. vdistance.y will return a positive number if vtarget.y is above vtrue.y. So fly up to bring vdistance.y to 0. And vice versa if under. And vdistance.z will return a positive number if the bounding box is smaller than we specified. So fly forward to make the bounding box bigger, or to bring vdistance.z to 0. Both are the same. And vice versa if the bounding box is too big. I quickly hooked up these controls, then excitedly took it for a test. And check this out. Whoops. It turns out I hooked up the wrong controls for when it sees a face. I meant to tell it to pan left if face is left, but instead told it to fly left. Take two. Check this out. Stop. Okay, it's gonna spin out forever. My face, look, I'm right here. Okay. Okay, so the drone kept rotating forever, and I couldn't figure out why. But after a good 10 to 15 minutes, I figured out that I hooked up the controls to vtrue instead of the v-distance vector that we worked so hard to make. Excitement clouds the logic of even the best of developers. So fix that stuff and take 3. Check this out. Oh, yes! Look at it! It's keeping me centered. I mean, it needs a little work, but it's working. Ladies and gents, boys and girls, here we go. I will be able to stand up on this flight. Watch this. Behold. I'm over here. Look at me. No. Okay. All right. Okay, can I stand up? Are you that flexible? You gonna stand with me? Oh, let me go. Okay, hold on. I went too fast. Hold on. Okay. All right. Look at this. We're off to a really good start. I can sit back down. Come on. Oh yeah. And then I finally decided to hook up the z-axis. Come on. Work that magic. Where are you going? I'm over here. Don't run into this. Okay, that's close enough. Back up. Oh no. Land. Okay. That was scary. And they say Skynet isn't going to happen. I hand controls over to the little bugger, and the first thing it wants to test out is attacking its master. Tello, I want you to land at once. Anywho, I wanted to fix some of the bugs I was facing. For example, I didn't give the drone enough of a safety zone. So if V-distance wasn't exactly on 000, which is impossible for our current technology for a drone to stay on, it would never stop trying to align itself, which is why you would see the swaying motion. Then, I forgot to make the safe zone encompass both negative and positive, which is what gave it this weird behavior. Excitement clouds the logic of even the best of developers. And with that, we were able to get these results. Yo guys, I am happy to report that we have done it. Check this out. I gotta make sure not to put this in my face. Don't fall, don't fall. Look at me, come here. All right, there it is. It got to my face. Tracked. Look at that precision. Look at that precision. It is directly on my face. I can stand up. I can stand up. Come with me. Come with me. Come with me. Come on. Come on. There you go. There you go. There you go. Look at that precision. I can walk over here. I can walk over here. Look at that. Look at that. Look at the streamers. Look at it. Look at this following me. Oh my goodness gracious. Come on. Come on. Oh my goodness, you see me? Do you see me? Look at it, look at it. This is autonomy right here. Come on, come on. Oh my gosh, would you look at that? Would you look at that? Guys, gals, and goofs, we've did it. Give yourself a slap on the forehead. I decided to add an offset to the vtarget.y so that we can get better framing without so much headroom. It was just too much. Then I decided to test it out in the long hallway. Then a visitor stopped by and I decided to use him as a guinea pig. So it's a bit sensitive. It only can take the front of your face, but like if you walk back, it'll start to walk with you.
Oh my god, that's so cool.
And if you walk forward, it'll do the same.
Oh my god, that's crazy.
And then like if you duck down, it should still, well you probably have to duck down a little slower. It loses, oh, it still got you, wow. Wow. And it worked out pretty good. Big shouts to Brandon. And yeah, it definitely works better on lighter skinned faces. Now, at this point, I was incredibly happy. I mean, we climbed all the way to the top of our ladder and succeeded. But there was this deep itch that wanted to try this out in the real world despite all the things that could go wrong. And seeing as I just needed a computer to connect to the drone, I got everything working on my laptop, coded in some fail-safes, and then said, what the hell? What good is a robot cameraman if you could never use him?
Track little drone, 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 track. My face little drone, face little drone, face. 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 Over here little drone, here little drone, here. 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 Now fly little drone, fly little drone, fly. Now fly little drone, fly little drone, fly. Fly little drone, fly little drone, fly. Now fly little drone, fly little drone, fly.
Alright guys, I hope that you guys enjoyed this week's episode, and I don't know about you, but I think this war has been won. Here's a salute to all you cadets out there, and for your Medal of Honor, link to the open source is in the description. Don't forget to buy a Teledrone though. And real quick, when I told IBM I was going to do a part 2, they asked me if I would kindly promote their next initiative, and seeing as this video wouldn't be possible without them, I graciously agreed. But heads up, this is not a sponsored video. It's more of a favor for some folks that I like. But I looked into their next initiative and it turns out to be something really cool for you as well. IBM is calling all developers to join their 2019 Call for Code Challenge to compete to win $200,000 if you have the winning solution. From free drones to $200,000. IBM sure knows how to party. One example for the challenge is from Puerto Rican developer Pedro Cruz, who is working on a disaster relief drone system powered by machine learning. The drones read symbols from the skies and relay important information back to relief workers. And I personally think it's a really cool and inspiring video, so link to that is in the description. But if you want more details or to enter the challenge yourself, you can register to enter by heading to ibm.biz/car2019. That's all caps and it's case sensitive. And my best wishes to all you guys to enter because it sounds like a lot of fun if I had the time. And I mean, $200,000 is some serious coin. But other than that, it's time to bake. Please do me a huge favor, subscribe to my channel if you haven't already, hit that bell icon to be notified when I upload the next video, and also, please come follow me on Twitter and Instagram to see like behind the scenes and whatnot. It's a fun time, I promise. And lastly, if you're interested in supporting my work beyond YouTube, please consider becoming a patron on Patreon for patronage. I just launched this little Patreon project called Hackspot Garden, in which all Patreon supporters create and customize a little hackspot for me to add it to my garden. So, if you're already a Patreon supporter, please check out the link in the description so that you can create and send me your hackspot. Please, I'm trying to fill this garden. And shout out to these top hackspot patrons for your support. Alright, I'm all done here. I hope to see you all next week, but whatever the case may be, remember to always feed your curiosity.